The places where people live were chosen because of the climate pattern that has been pretty much the same on Earth since the end of the last ice age 11,000 years ago. Here on this farm, the patterns are changing. And it seems gradual in the course of a human lifetime, but in the course of time as defined by this river, it's happening very, very quickly. Two canaries in the coal mine. The first one is in the Arctic. It's, of course, the Arctic Ocean, the floating ice cap, Greenland on its side there. I say canary in the coal mine because the Arctic is one of the two regions of the world that is experiencing faster impacts from global warming. This is the largest ice shelf in the Arctic, the Ward Hunt ice shelf. It just cracked in half 3 years ago. The scientists were astonished. These are called drunken trees, just going every which way. This is not caused by wind damage or alcohol consumption. These trees put their roots down in the permafrost, and the permafrost is thawing, and so they just go every which way now. This building was built on the permafrost and has collapsed as the permafrost thaws. This woman's house has had to be abandoned. The pipeline is suffering a great deal of structural damage. And incidentally, the oil that they want to produce in that protected area in northern Alaska, which I hope they don't, they have to depend on trucks to go in and out of there, and the trucks go over the frozen ground. This shows the number of days that the tundra in Alaska is frozen enough to drive on it. 35 years ago, 225 days a year. Now it's below 75 days a year because the spring comes earlier and the fall comes later and the temperatures just keep on going up. I went up to the North Pole. I went under that ice cap in a nuclear submarine that surfaced through the ice like this. Since they started patrolling in 1957, they have gone under the ice and measured with their radar looking upwards to measure how thick it is, because they can only surface in areas where it's 3.5 feet thick or less. So they have kept a meticulous record, and they wouldn't release it because it was national security. I went up there in order to persuade them to release it, and they did. And here's what that record shows. Starting in 1970, there was a precipitous drop-off in the amount and extent and thickness of the Arctic ice cap. It has diminished by 40% in 40 years. And there are now two major studies showing that within the next 50 to 70 years, in summertime, it will be completely gone. Now, you might say, why is that a problem? And how could the Arctic ice cap actually melt so quickly? When the sun's rays hit the ice, more than 90% of it bounces off right back into space, like a mirror. But when it hits the open ocean, more than 90% of it is absorbed. And so, as the surrounding water gets warmer, it speeds up the melting of the ice. Right now, the Arctic ice cap acts like a giant mirror. All the sun's rays bounce off more than 90%. It keeps the Earth cooler. But as it melts, and the open ocean receives that sun's energy instead, more than 90% is absorbed. So there is a faster buildup of heat here at the North Pole, in the Arctic Ocean, and the Arctic generally, than anywhere else on the planet. That's not good for creatures like polar bears who depend on the ice. A new scientific study shows that for the first time they're finding polar bears that have actually drowned, swimming long distances, up to 60 miles, to find the ice. And they didn't find that before. But what does it mean to us to look at a vast expanse of open water at the top of our world that used to be covered by ice? We ought to care a lot because it has planetary effects. The Earth's climate is like a big engine for redistributing heat from the equator to the poles. And it does that by means of ocean currents and wind currents. They tell us, the scientists do, that The Earth's climate is a nonlinear system, just a fancy way they have of saying that the changes are not all just gradual. Some of them come suddenly in big jumps. On a worldwide basis, the annual average temperature is about 58 degrees Fahrenheit. If we have an increase of 5 degrees, which is on the low end of the projections, look at how that translates globally. That means an increase of only 1 degree at the equator, but more than 12 degrees at the pole. And so all those wind and ocean current patterns that have formed since the last ice age and have been relatively stable, they're all up in the air, and they change.